Hey guys, this is 1.1. We are talking about linear equations today. Welcome. And remember, only write down things that are new to you or that you would need to know, okay? So, a linear equation just refers to, that comes from the word line, right? Or has the same root. We're talking about the coordinate plane. Linear equations will make a line if you graph them. It's in the form ax plus b equals 0, and the largest exponent is an understood 1. So by exponent, they mean that the x is raised to the first power at the most. And x squared is not going to give you a straight line. It's going to give you a curve in your line. So it is not, there are no exponents except the exponent of 1 or an exponent of 0. Good? All right, so when we solve linear equations, list restrictions on the domain of the variable. That means make sure that there are no variables in the denominator, and there are no variables under a radical. If there are, then you need to eliminate any numbers, any values of x that would make the denominator of a fraction 0 or make the square root, the radicand of a square root, a negative number. Okay, you would have to remove those, so you just make a list. D, the domain is not all real numbers. The domain is all real numbers except x cannot be. Okay, then we're just going to clear parentheses, isolate the variable to one side using inverse operations and collecting like terms. First, undo addition and subtraction, then undo multiplication and division. Good. Put your answer back into the original equation to verify that it is a true statement. Good. All right, so our first examples. Number 1 is 4x minus 5 equals 7. 4x minus 5 is 7. Again, it said to use inverse operations to solve for x or to solve for whatever that variable may be. Do the addition and subtraction first. So x is being multiplied by 4, and then 5 is being subtracted from it. So I'm going to add 5. Anything I do to this side of the equation, I have to do to the other side. 4x is, that's gone, right? 7 and 5 is 12. Now I have 4x equals 12. X is being multiplied by 4, so I want to do the opposite of that, which is divide by 4. 12 divided by 4 is 3, so x is 3. To check it, you're going to say 4 times 3 minus 5. And if you get 7, you know you've found the right answer. Okay? All right, number 2. Ooh, went straight to a more difficult one, right? Number 2 is x plus 10 times x minus 2 equals x plus 2 squared. So I said we can't have any exponents raised to a power greater than 1, right? We said that. This is not an exponent raised to a power greater than 1. This is the whole binomial being multiplied by itself. So what we're going to do with that is rewrite it. This is x plus 10 times x minus 2 equals x plus 2 times itself, right? We're going to solve those. X times x with FOIL is x squared, x times negative 2, x times 10, and then 10 times negative 2 is a negative 20, equals x times x is x squared, x times 2 is 2x, 2x times x is 2x, 2 times 2 is 4. Okay, let's keep simplifying. X squared, negative 2x and 8x are, and 10x are 8x, minus 20 equals x squared. Here, 2x and 2x become 4x plus 4. Good. Okay, now we have combined like terms on either side of the equal sign, so now we want to move things, all right? It doesn't matter whether you move all of the variables to the left or to the right. They are the same, the x squared are the same. The 8x is bigger than the 4x, so I might move it this way. Start with the x squared. To move it, you just want to subtract x squared. You'll be left with 4x plus 4 on this side. Anything you do to that side, you have to do to this side. So x squared minus x squared, they fall out. And what you are left with is 8x minus 20 equals 4x plus 4. So even though we did temporarily have x raised to the second power, because there was one on either side, we could subtract them out and they're gone. All right, so now this is another manageable one. Again, I'm going to keep moving it over here. So I'm going to subtract the 4x, subtract the 4x. Make sure you're putting the like terms below in line, lining them up together, right? You wouldn't want to put the 4x under the 20. And you're also welcome to move the 20 at the same time. You could say plus 20 here, or you can move it down here, plus 20, plus 20. That cancels, and you get 4x equals 24. Oh, I'm always tilted. I'm sorry, that's annoying. Now, last step is x is being multiplied by 4. You're going to divide x by 4. 24 divided by 4 is 6, so x is 6 for that second example. And you just want to carefully put it back into your equation. 6 plus 10 would be 16. 6 minus 2 is 4. So 16 times 4 is equal to 8 squared. Okay, I don't want to, this is a longish lesson, so I'm not going to check my answer, but I strongly encourage you to check all of your answers. Is that bad? Next, we have 1/2 x minus the square root of 3 equals 0. Okay, when something is set equal to 0, you can, it doesn't really mean anything. It's just like being set equal to any other number. So you can still move things. Here, x is being multiplied by 1/2, and then we're going to subtract the square root of 3, just like this one, right? Except that it happens to be a square root of 3. One second. I can't get that in focus enough for my taste. The only difference is it's not a whole number, right? So we're going to add square root of 3 on this side, add square root of 3 to 0. Luckily it's 0 because it's easy to add square root of 3 to. You just end up with the square root of 3 is equal to 1/2 of x. Remember that 1/2 of x is the same as x over 2. So if the x is right next to it, it's the same as it being in the numerator of the fraction. Good? So what do we need to do here? I'm even going to write it like that. I'm going to say it's x over 2 equals the square root of 3. Or x is being multiplied by 1 and then divided by 2, right? X multiplied by 1 is just x. Now I can see that what I need to do to solve for x is just the opposite of divided by 2. Multiply by 2. Anything I do to that side, I need to do to this side. Those cancel. X is 2 square root 3. Okay, you can put that back right here to make sure that 2 square root of 3 times 1/2 minus square root of 3 is equal to 0. Good. Now I have, for number 4, I have 6 minus x equals 2x plus 9. Again, move the variables to one side, the constants to the other. I don't like my variable being negative, so I'm going to move this negative x. Now I have 6 is 3x plus 9, right? Now I need to move the 9. 6 minus 9 is a negative 3. Negative 3 is equal to 3x. You can see possibly where it's going. I need to divide by 3. Negative 3 divided by 3 is a negative 1. So x is negative 1. Okay, put that back in there to make sure that we are correct. Number 5 is 7 minus the quantity 2x minus 1 is 10. So we learned this in our 4. This minus sign is a negative 1. So 2x is going to be multiplied by negative 1. And then negative 1 is going to be multiplied by negative 1. All right, so I'm going to distribute that minus sign. 7 minus 2x plus 1 is 10. I distributed the minus sign. Now combine like terms. 7 and 1 is 8. 8 minus 2x is 10. The variable is already, or sorry, the constant is already alone over here, so I'm just going to move the 8 over there. There's fewer steps, but it does make my variable a negative. That's okay. It's being multiplied by -2, so I'm going to divide it by -2. X is 2 divided by -2. 2 divided by 2 is 1, right? But a positive divided by a negative is a negative, so x is -1 again. Both 4 and 5, the answer was x is -1. Our sixth example is 3 times the quantity 2 minus x is equal to 2x minus 1. Distribute the 3 just like we distributed that minus sign, okay? Here 7 is, we're subtracting a binomial from 7. Here we're multiplying a binomial by 3. 3 times 2 is a positive 6. 3 times a negative x is a negative 3x equals 2x minus 1. Now we're just back here looking like number 4, where you just have constant variable on one side, variable constant on the other, and you just move them to put the like terms together. You can't say 6 minus 1 because they're on different sides of the equal sign. Instead, you can say, I'm going to move that one over by doing the inverse. 2x equals 6 plus 1 is 7 minus 3x. Good. Now I'm going to move the 3x over. It's a negative 3x, so I'm going to add 3x to both sides to cancel it over here. But it will exist over here. 2 and 3 is 5x. Last step, x is being multiplied by 5, so I'm going to divide it by 5. And at the end you have x is 7/5. Okay? What's our seventh example? Ooh, it's a long one. All right, let's see if I can fit it. X times 1 plus 2x equals 2x minus 1 times x minus 2. Okay? Let's see if I even wrote it right, because that'd be bad if I didn't. All right, first on the left side, what we need to do is we have a monomial times a binomial, so we're going to take that monomial and distribute it. X times 1 is x. I'm going to put it way over here because I know I'm going to run out of room. That x times a positive 2x is 2x squared, because x times x is the x squared, but the 2 remains just a 2, right? Equals, now we have to FOIL. So 2x times x is 2x squared. Good. What other colors do I have? Nothing, just a bunch more blues. Next we have 2x times -2. 2 times a -2 is a -4. Keep the x, okay? Now move on to the -1. -1 times x is a -x, and then -1 times a -2 is a +2. I didn't run out of room. That wasn't too bad. Okay. X plus 2x squared. I'm just going to put them in standard form or in descending order. So I'm going to put the bigger exponent in front. 2x squared. I'm going to immediately combine the like terms, -4x and -1x, right? -4 minus 1 is a -5x plus 2. So now we have 2x squared plus x equals 2x squared minus 5x plus 2. Same problem where we suddenly have an x raised to an exponent that is not 1. That's bad, but I think if we subtract it from this side and subtract it from this side, it will fully disappear and we'll just have x is -5x plus 2. So because it was the exact same value on either side of the equal sign, when we tried to move it, it disappeared. Here I have a negative 5x and one constant. Here I just have one positive variable. But if I just move, well, luckily, if I move the 2 over here, I still have the same problem where the x is separated. So I want to move the x over. And luckily, it will make it all positive. So over here, I'm left with 2, 6, sorry, 5. Got ahead of myself. Subtracting 5x here, so I'm going to add 5x, 5x and x is 6x. X is being divided by 6, or multiplied by 6, so I want to divide it by 6. Sorry, I just keep like talking ahead of what my hands are doing. 2 over 6, right? But if I think about 2 divided by 6, both of those can be divided by 2, or both of those can be the fraction can be put into lower terms. So if I take 2 and divide it by 2, and 6 and divide it by 2, 2 divided by 2 is 1, 6 divided by 2 is 3. So 2 6 is also 1/3 because they have a common factor. One common factor of 2 and 6 is the number 2. So I can divide them both by that common factor and get a more simplified fraction. I think I stopped writing the answer, sorry. So this guy was x is 1/3. This one was x is 7/5. This one and this one were both -1. Okay, so that's how you're going to solve linear equations without fractions, right? We did not deal with any fractions except this kind. Now, let's talk about fractions, okay? Equations with fractions. When you have fractions, you might have a fraction with x next to it, you might have a fraction with x in the numerator, or you might have a fraction with the variable in the denominator, okay? What you want to do is clear all grouping symbols, identify the least common denominator, the smaller the number all denominators will divide into evenly, then multiply the entire equation, both sides, by that least common denominator. So let's talk about fractions. Numerators are on top, denominators are on the bottom, okay? Once you've cleared grouping symbols, you're going to look at your denominator, okay? In this case, it's 2, 4, y, 2, 2, 8, 4. Well, no, we haven't distributed those yet, okay? I've just made it difficult to see, I apologize. Should not have used purple. Here's a new one. Our denominators are 2, 4, 2, 2, 8. Don't look at these yet, okay? Identify the least common denominator. The smallest number all denominators will divide into evenly. When we were talking about changing 2 6 to 1/3, I said 2 is a factor of 2 and 6. We are not talking about factors, okay? We're talking about denominators or multiples, okay? A factor is something you would divide out of it. A multiple is something you would multiply it into, okay? So you're going to make here, we made the number smaller, right? 6 divided by 2 is 3, 2 divided by 2 is 1. Here we're going to make the numbers bigger because the rules for from adding and subtracting fractions is that you have to have the same denominator, okay? So we want to either get rid of all the denominators or make the denominators the same so that we can start combining them. Okay, let's get started. For real. All right, the first one is 1/2 x minus 5 equals 3/4 x. Again, our denominators are 2 and 4. Okay, I'm going to move that now because I need more space. My denominators are 2 and 4. The smallest number I can divide by both 2 and 4 is 4. 2 times 4 is 8, so 8 is a common denominator. But I want the smallest one I can possibly find, okay? Now that I have that, I want to take every part of the equation, there are 3 parts, and multiply it by the least common denominator. Not by a fraction, just by the least common denominator. So I have 1/2 x, I have -5, and I have 3/4 x. My least common denominator is, my least common denominator is 4. So I'm going to take that 1/2 x and I'm going to multiply it by 4. I'm going to take -5 and I'm going to multiply it by 4. And I'm going to take 3/4 x and multiply it by 4. Okay. Also remember, it is the same as x over 2 minus 5 equals 3x over 4. All right. That number, the x behind the number is the same as the x being in the numerator. So I'm going to multiply that by 4, multiply that by 4, multiply that by 4. 4 divided by 2. 4 divided by 2 is 2. -5 times 4 is a -20. 3 times x times 4 divided by 4, they just completely cancel, right? Here, 4 divided by 2 becomes 2. Here, 4 divided by 4 becomes 1 and just goes away. Okay? That's what we're doing. Now I just have a normal equation with no fractions. I have a 3x over here, a 2x over here, but there's a -20 here, so I'm going to move the 2x. -20 is 3x minus 2x, x. Good? All right, next one. The next one is 2 over y, or 2 over x, it doesn't matter, plus 6 over y equals 2. All right, we're talking about denominators. The least common denominator that both y and y can multiply to become, right, is just y. Least common denominator, y to the first power. So I'm going to take y and I'm going to multiply each part of this 3-part equation by y. That is going to get multiplied by y. That is going to get multiplied by y. And then that's going to get multiplied by y. I try to like space it out so that I have enough space to write, but I just wrote a ton of space between those two and none for that one. Doesn't matter. Again, just like 4, x is being multiplied by 4 and divided by 4, so you can just ignore it, right? 2 is being multiplied by y and divided by y, so that just goes away. Y divided by y is 1. It just remains 2. 6 is being divided by y and then multiplied by y, so it's just 6. 2 is being multiplied by y. Good. So here we had a y in the denominator, a y in the denominator, no y over here. By multiplying everything by that denominator, I now just have 1 y over here. 2 plus 6 is 8. Just like with x, y is being multiplied by 2, so I divide it by 2. Y is 8 divided by 2, or y is 4. Okay? Our third example with fractions is x plus 5 over 2 plus 1/2 equals 2x minus x minus 3 over 8. I should write it all spaced out here so I don't have to write it again, just to have the space to do the least common denominator. So the numbers 2 and 2 have a common denominator of 2, but over here we have an 8 and we want to make sure it's a common denominator for every term. Okay, this is just a 1, right? There's no fraction. 2, 2, and 8, you can divide 8 by 2, you can divide 8 by 8. So we're going to use 8 as our least common denominator. It's 8. Okay? Okay, I was tired of rushing through writing it. I'm going to take my first term, multiply it by 8. Take my second term, multiply it by 8. Multiply this by 8. Multiply this by 8. And remember, it's a negative, so I should put, well, it doesn't matter. Now it's a negative 8 times this, or an 8 times negative that, right? This one's going to be a positive, this one's going to be a positive, this one's going to be a positive, but this one, just like it was a negative here, is going to remain a negative. So here we said 4 divided by 2 becomes 2, right? 8 divided by 2. What happens when you take 8 and you divide it by 2? Because right now that x is there's going to be 5 added to it, and then it's going to be divided by 2, and then it's going to be multiplied by 8. But we can simplify this. 8 divided by 2 becomes 4, right? And then you still have that x plus 5. So now we're saying it's 4 times x plus 5 instead of 8 times x plus 5 divided by 2. Good? Same here. Here's a positive 8 being divided by 2. 8 divided by 2 is still 4. 4 times 1 is just 4. Here, there's nothing in the denominator, so we're just going to say it's 8 times 2x. You can go faster than me if you want, if you know what that is. Here's a negative, so I'm going to call it minus. 8 divided by 8 is 1, right? So this we're just going to call minus x minus 3. Why did I put the x minus 3 in parentheses? Because I don't want it to get lost. I don't want this to always stay in negative 3. I need to distribute that minus sign. Or if this had been a 4, right? If this had been a 2, then I would have 4 times x minus 3. I wouldn't want it to just be 4 times x and then forget to distribute the x to the minus 3. So even though I didn't have parentheses up here, start adding parentheses as your equation becomes more complex so you don't make any mistakes. All right, fractions are gone. Distribute that 4. That's now 4x plus 20 plus 4. Now I can get rid of my parentheses because I've dealt with all of them. 8 times 2 is 16. Distribute the negative sign. Minus x, but plus 3. Good. Now just combine like terms. 20 and 4 become 24. 16x minus x becomes 15x. 4x over here and 3 over here. Good. The 15x is bigger than the 4x, so I'm going to move the 4x. I get a 24 over here. 11x plus 3, move the 3. And I get 21 is 11x divided by 11. Final answer is that x is 21/11. And I know I switched their sides, but you don't need to change anything if you're just switching the sides, as long as it's an equal sign and not an inequality sign. The last two examples, we are asked to distribute a fraction first. I'm going to skip them because there are no distributing of fraction problems in my math lab. All right, so what we've got is that x equals 20 here, y equals 4 here, and x equals 21 over 11 here. Okay? Now, what if you do have many things in the denominator of your fraction? You don't just have x, you don't have a common denominator, you have two different binomials. What should you do? What you should do is treat that just like any other denominator problem, and to get rid of 2x minus 3 in the denominator of your equation, you want to multiply that. Multiply every term in your equation by that to cancel it, right? Because 2x minus 3 times 2x minus 3, 2x minus 3 times 6 divided by 2x minus 3 is going to cancel, just like 6 times 8 divided by 8 is going to cancel the 8s. Okay, so to get rid of this denominator, I'm going to multiply this side by this. Anything I do to this side, though, we know we have to do to the other side. So we're ignoring this one. We're just dealing with this one, and we're going to multiply both sides of the equation, or every part of the equation, by 2x minus 3. Okay, so now what I have is 2x minus 3 times 6 divided by 2x minus 3. It's the whole reason we did it, and it's because this cancels, right? So now on this side, all I have is 6. Here, I have 4 times 2x minus 3 divided by 2x plus 5. Okay? So in order to get rid of the 2x minus 3, I multiplied that whole binomial by every term. There were only 2 terms, by this term and by this term. Okay, what I got was cancellation, so I just got my number here, and here I got 4 times 2x minus 3. Now, I still have one denominator, right? That denominator, I don't want it here either. 2x plus 5, how do I get in the denominator? How do I get rid of it? By multiplying it by 2x plus 5, right? So everything in the equation, this term and this term, I'm going to multiply by 2x plus 5. Okay? So on this side, we now have 6 times 2x plus 5 equals, again, just like up here they canceled, this cancels this, and I have equals 4 times 2x minus 3. This might look familiar to when you were adding and subtracting fractions in some former math class. Now I got rid of my fractions. I just distribute the 6. 6 times 2x is 12x. 6 times 5 is 30. 4 times 2 is 8x. 4 times a negative 3 is a negative 12, right? I'm going to move my 8x over because 12 is bigger. 12 minus 8, 4, right? 4x plus 30 is negative 12. Now I'm going to subtract that 30. I have 4x on this side. Negative 30 minus 12 is a negative 42. You can't, let's keep going. Let's divide by 4. Divide by 4. X is negative 42 over 4, which doesn't divide into a whole number, but we can simplify them both by 2, right? Or we can divide them both by 2. Negative 42 divided by 2 is a negative 21, and then 4 divided by 2 is 2. So x is negative 21 halves as our answer for this problem. All right, I feel like we might need to do one more example of this style. So I'm just going to say x over x plus 6 is equal to 7 over 6. Okay, this is right out of my math lab. You might see this on my math lab while you do this homework. You want to look at your denominators, okay? Don't worry about a common denominator, just look for your denominator. X plus 6. To get rid of x plus 6 in the denominator, I'm going to need to multiply everything by x plus 6. So I'm going to take x plus 6 and multiply it by x over x plus 6. And then on this side too, you have to do everything the same to every term in the equation. Good? So just like up here, we had 2x minus 6 in our denominator. We put it in the numerator for both parts of the equation. Cancels. Here, it just gets multiplied by 4. Okay? Right there, it's preserved there. It's preserved there until we distribute the 4, and then we just solve it like a regular math problem with no fractions. Like fractions aren't math. Good? So here, those cancel. We just have x on this side equals x plus 6 times 7 all over 6. You see that? Because it's in the top, just like over here, just it's in the top, so it becomes part of the numerator of the fraction. The denominator stays the same. So our denominator was 6. We still want to get rid of the 6, okay? Here, the x plus 6, we got rid of it by multiplying it by x plus 6. We want to get rid of a 6, so we're going to get rid of it by multiplying by 6. Now we have 6x on this side equals x plus 6 times 7 on this side, which is better written as 7 times the quantity x plus 6, right? We'll just distribute that now. The 7 becomes 7x plus 42 equals 6x. 6x equals 7x plus 42. Even though it's going to make it a negative, I'm going to, no, you know what? I'm going to move the 42. But it's not wrong to move the 7. Good. So now I have 6x minus 42, or I have negative 42 plus 6x equals 7x. Good. Subtract 6x, subtract 6x. Negative 42 is x. So that is how to deal with denominators that are a bit complicated. You don't even have to find a common denominator. You can just do them one at a time, right? Even if we went back and did our other fractions one at a time, right? I could multiply everything by 2. This times 2, this times 2, this times 2. The 2 wouldn't make the 4 go away, and then I could go through and multiply everything by 4. So you can take it as slowly as you want. It doesn't have to be a common denominator. You can do each part of the denominator on its own. Okay, if the variable cancels, if the remaining statement is false, there is no solution for the equation. If the remaining statement is true, there are infinite solutions for the equation. Okay, so here we have 3x plus 5 equals 3x plus 3 times the quantity x plus 2. Let's distribute the 3, we get 3x plus 2. If you look at this right now, you're going to say, there's no x that makes that true, right? But we'll just keep going. 3x, we'll subtract the 2, we get 3x plus 3 equals 3x. When I try to move the 3x, it disappears. 3x minus 3x is 0. So 3 equals 0. That is not true, so this is no solution. Okay? Or even when you get up here, you could say 3x plus 3 equals 3x. I'm going to divide everything by 3 to try to find x. X plus 1 equals x. It's just not true, right? So here, then you would have subtract x, 1 equals 0. Still no solution, okay? Or you have 3x plus 3 equals 3x. And then you change it, you divide by 3, divide by 3, divide by 3. You get x plus 1 equals x. You divide by x, divide by x, divide by x, right? Then you get 1 plus 1 over x equals 1. No matter what you do, you'll eventually get to something equals 0, and it's not true, right? That cannot. Oh, and then you have to multiply by x. Anyway, it can look different ways, but you're going to end up with something that is no solution. It's okay if one side is 0. It's okay if it's 5 equals 4. That's still just not true. Okay? All right, here we have 2x over x plus 3 equals negative 6 divided by x plus 3 plus 2. Another opportunity to practice how to do fractions, okay? So I have a denominator of x plus 3, right? I don't even care what the rest of the equation says. I want this gone. I'm very afraid of this, okay? If I'm very afraid of this, what I'm going to do first is what I'm going to do is take that and multiply everything by it so that I can get rid of it. Well, that wasn't a fraction, so I put it way too high. It's confusing. Because that's just the number 2. Okay, here, x plus 3 times 2x divided by x plus 3 means those cancel. I get 2x. X plus 3 times negative 6 divided by x plus 3. Yay, those were the same. They cancel. Negative 6. Here I have plus 2 times x plus 3. Is that okay? Sorry, I know that was confusing. I just didn't like my placement. So I'm just taking that part, multiplying it by x plus 3. That part, multiplying it by x plus 3. That piece, multiplying it by x plus 3 to get rid of this x plus 3. It happened to also get rid of this x plus 3. Yay. 2x, it's okay if it doesn't, equals negative 6. I'm going to distribute the 2. 2 times x is 2x. 2 times 3 is 6. Good? Okay. Negative 6 and 6 combine, but they just make 0, right? So that's actually just 2x equals 2x. That is always true, so those are infinite solutions. This one can also look different. So it might be 2x equals 2x, and you want to keep going. So you say, all right, divided by 2. It's still going to say x equals x, right? Subtract x, 0 equals 0, okay? So if you have 0, that doesn't mean no solution. If it's 0 equals 0, that's infinite solutions. If it's 0 equals something that's not 0, it's no solution, all right? Even here, when we had 2x equals negative 6 plus 2x plus 6, if I wanted to subtract the 2x right now, then it would just be 0 equals negative 6 plus 6. That's true, right? I could even move this 6 over. Subtract 6, and I would get negative 6 equals negative 6. So there are many ways to see it. Negative 6 equals negative 6, 0 equals 0, 2x equals 2x, or divide by 2 and get x equals x, right? But the point is these are all true, so it's infinite solutions. None, ignore that one. None of these are true. Not true, not true, not true, no solution. Okay, so they'll disappear. Generally, you can get your x's to disappear. If what you're left with is false, no solution. If it's true, infinite solutions. Now, solving for an indicated variable when you have no numbers. This is important. PV is our first example, equals N R T, and they're asking us to solve for T. To solve for T just means like solving for X. What does T equal? Okay, so right now T is being multiplied by R and multiplied by N. I want to divide it by R. Anything I do to this side, I have to do to this side. So now it's PV over R equals, those cancel, NT. Good. Now T is being multiplied by N, so I want to divide it by N. I'm going to divide all of this by N, so I'm just going to add the N next to the R. Good. Now I have PV over RN equals T. So here I was multiplying them by T, so I'm going to divide everything else by them. So T equals PV over RN. Here we have one number and we have two numbers and two letters. We want to solve Fahrenheit equals 9/5 Celsius plus 32 for Celsius. Subtract the 32, subtract the 32. So now I have F minus 32 is 9/5 C. Good. C is being divided by 5, but being multiplied by 9, right? So if I want to get rid of that denominator, get rid of that 5, I'm going to multiply everything by 5. 5f minus, what's 5 times 32? 160. 5f minus 160 is 9c, right? Now I need to divide it by 9 to get c alone. I would just leave it like that. 5f minus 160 over 9 equals c. Good? Here we have p times 1 plus r times t for r. Oh, sorry, a equals. First, I'm going to distribute that p. A equals p plus PRT. I'm going to subtract that p. It's not like the a, so we have now a minus p equals PRT. I didn't like my example here where I went one by one. If t is being multiplied by n and r, just move them both at the same time. Good? I like that better. So here we have a minus p equals p times r times t. I'm solving it for r, so I'm going to divide it by pt. R is being multiplied by p multiplied by t, so if I divide it by those, they will cancel. Anything I do to that side, I have to do to this side. So I have r equals a minus p divided by, pt. R equals a minus p on top, pt on the bottom. Good? Here, just a note, okay? All of your variables are in the denominator. Oops, 1 over b. 1 second. No matter what they were asking me to solve this for, I would get them out of the denominator first. Okay, so I want this one gone, so I'm going to multiply everything by s. Right? Now I have 1 plus s over q equals s over b. Right? I want this one gone, so I'm going to multiply by q, multiply by q, multiply by q. 1 times q is q. S times q divided by q is just s. S times q over b. This one's being divided by b. I want the b gone, so I'm going to multiply everything by b. Good. And then if they ask you to solve for one of them. All right, so now, for example, if you needed to b times q plus s times b equals sq. If you needed to solve for b, for example, these two you can factor out of b, right? You can divide this by b, divide this by b, call this b times q plus s, right? bq plus bs or sb is the same as b times q plus s, right? Equals sq. Solving for b, so now I'm going to just move that whole, it's being multiplied by b, that whole binomial. B is sq over q plus s, or s plus q. All right, our last examples are word problems. Basically, they're telling you a story and they want you to put it into or create an equation and then solve your own equation. So a total of $10,000 is to be invested, some in stocks and some in bonds. If the amount invested in bonds is 1/4 that invested in stocks, how much is invested in each category? So we actually have two different equations, okay? Here's our first one. A total of $10,000 is in stocks and bonds. Right? And we also know the amount invested in bonds. So B, right? The amount invested in bonds is just going to be the letter B, is 1/4 that invested in stocks. Bonds is 1/4 of stocks, and stocks and bonds together is $10,000, right? How much is invested in each category? Then you can take either one of these and, well, no, I guess not either one. You can use these two equations to solve for either S or B, right? So we have 10,000 equals S plus B. B is 1/4 S. I can't solve an equation that has two variables. I'm solving equations that have been in one variable so far, right? So I want to take that B and I want to put it in terms of S, we say. B in terms of S is 1/4 S. So we know that 10,000 equals S plus 1/4 S. See how I did that? So instead of bonds being bonds, bonds are actually just another quarter S. 10,000 is 1S and a quarter S, or 0.25, right? Because 1/4 is 0.25. 1 and a quarter good. Now S is being multiplied by 1.25 because we combined those two. The bonds is 0.25 and the stocks is one stock, right? 1 unit of stock. We got 1.25. We're going to divide it by 1.25 to find out what S is. If we take 10,000 and divide it by 1.25, we get 8,000. We have $8,000 in our stocks. And if we say 10,000 equals S plus B, 10,000 equals 8,000 plus B, that means B is equal to 2,000, right? And is 2,000 1/4 of 8? So that was 2,000 equals 1/4 of S. S is 8. So this is just to check your answer. 8,000 times 1/4 is 2,000. So we've used the two equations, we've created two equations, solved them took one of the equations, allowed it to put one of our variables in terms of the other for the other equation, and then solved for both of them, okay? Next, going into the final exam, which is 3 tests, a student has a 72, 59, 75, and 77. What does that student need on the final exam in order to have a 70 as his or her final course grade? So we need to know what averages are, right? And we need to read it closely to see that this final is 3 test grades. It's 1 test, but they're getting 3 test grades out of it, okay? The teacher is. How many, so an average, right? My average final course grade is just the average of the exams, I guess. Sorry, I wrote that badly. So the average means we add all of the examples together and divide by the number of examples we have, right? So how many tests we have? We have this test, this test, this test, this test, and we have the 3 final exams. Those were supposed to be T for test, but this looks like plus signs. So we have the 4 tests this person's already taken, and then the 3 final exam grades are all test grades too. So how many T's do we have total? How many tests do we have total? 1, 2, 3, 4, 5, 6, 7. We have 7, right? And this person wants a 70% for 7 tests, 7 test grades. So your test grade multiplied by 7 and divided by 7 should equal 70, right? So what do we have? We can replace some of these T's. So we have 7 T's. We can replace some of them with her actual scores. So 70 equals 7T over 7. She has grades of 72, 59, 75, I'm just saying her, sorry, and 77, and she has 3 mystery grades, right? Those all need to add up to how many points, right? If I take her number of tests, multiply it by 7, divide it by 7, I should get at least a 70. Maybe she wants exactly a 70. She has some sort of bet going, right? So let's work backwards. 7, the T is being multiplied by 7 and divided by 7. So let's take 70 and divide it by 7. $70 times 7, is that a biblical reference? Equals 7T, right? So all 7 of the T's should equal 490. Right now she's already finished 4 of the T's, so we can't change those, but we'll still have 3 T's. So 490 are these 7 T's, but some of them are already done. 1, 2, 3, 4, 5, 6, 7. Yeah? So these can just be called 3T, right? So we have 72 and 59 and 75 and 77 and 3T is equal to 490. Let's combine like terms, which is what we did here. We combine like terms. 72 and 59 and 75 and 77. Is it 70? 70 times 7, yeah. 59 and 75. I did a multiplication sign in there. So that's not a grade you can get. All right, 283 are all. Oh, this girl's in trouble. 283 and 3T need to add up to 490. Yeah? Keep solving it. So we're solving for T. What does she need to get? Minus 283 minus 283. Now we just have 3T is 490 minus 283, 207. Yeah? 207 divided by 3 is, oh, she's fine. She needs to get a 69 on all the rest of her tests. Not all the rest of her tests, on her one test that's worth 3 test grades. 69, 69, 69, 77, 75, 59, and 72 should equal 490. Divided by the 7 exams, we'll give her a 70% in the class. So she needs a 69%. Good? I know I'm kind of rushing. This woman is paid time and a half for hours worked in excess of 40 hours and double time for hours worked on Sunday. If she has weekly wages of $1,083 for working 50 hours, 4 of which were on Sunday, what is her regular hourly rate? Okay? So she gets $1,083, right? What did she do? She got a total of 50 hours, right? She did 4 Sunday hours. She did, I guess you can only work 40 regular hours, right? She got 40 hours, 4 Sunday hours. 50 minus the 4 is 46. Minus the 40 is just 6. So she had 6 overtime, right? I'll write an O, but I'm scared. I'm gonna call it V. And 6 overtime hours. So she worked 50 hours, but 4 of them were on Sunday and 6 of them were overtime, 40 were regular, right? What happens to her hourly rate? We're trying to find an hourly rate, but your hourly rate is just here. But what about on Sunday? Your hourly rate on Sunday is, sorry, you couldn't see that. So her hourly rate is just her hourly rate. Her Sunday rate is 2 hourly rates, and her overtime with a V is time and a half, 1.5 hours. Good? So she gets paid 1.5 times her regular salary for these 6 hours. She gets paid twice her regular salary for the 4 hours, and she gets paid her regular salary for the 40 hours. Good? So this becomes 4 times 2H. This becomes, this stays 40H, right? Because H is just H. And then the 6 hours get paid at 1.5 times her regular rate. Now we can just combine like terms. Let's get rid of the parentheses. 4 times 2 is 8H, 40H, and 6 times 1.5, 9H. So you see how we can translate her overtime hours into hours, her hours into hours, and her Sunday hours into hours. You have a different number than you actually worked, but that's how much they paid you to work. Good? Combine like terms. 8 plus 40 plus 9 is 57, and then just take that 1083 and divide by 57, and you get $19 an hour. Good. The last one is a percent. The bookstore marks up the price it pays for books by 30%. The selling price of the book is $79. How much did they pay for the book? You want to make an equation, okay? Your equation is $79 is the price of the book plus another 30% of the price of the book, right? 1/4 is 0.25, 30% is 0.3 of the total price. So just like we did with the stocks and bonds, we're going to combine 1p and 0.3p to get 79 equals 1.3p, and then we just take that 79 and divide it by 1.3. $60.77 is the price of the book, as the price they paid for the book. And then that's $19 per hour. All right, sorry, that was a long one, guys, so I'm just going to cut it off there. Thank you so much. See you soon.